Okay. So the only topic left for differentiation, it is traits of change. And this is slightly different from the usual differentiation that we have done till now. So what would you have? They would give you the main equation. Okay, we know it would be y in terms of x, the main equation, or it can be any other two variables as well. Just like we differentiate and find the turning points and find a dy by dx, we differentiated the usual way. So you would have the original equation, and then they would give you rates of each of them with respect to time. Rate of dy by dt, dy by dt as well, and you will see that dx by dt as well. You would now see another variable. So you will have x, y, the two usual variables that you know about these two, that you will have the equation in, and then you would have the third variable as well, time, or it can be other variable as well, any other variable as well. So a third equation, sorry, third variable. So you will have to understand the situation and you will see how things work along with it. And first of all, the formula for the rate of change, it is somewhat like this: the dy by dx, it will be equal to the dy by dt divided by dx by dt. So your dy by dx is equals to, you can see the rate of change of y with respect to time divided by rate of change of x with respect to time. So if you want to write the y and x in terms of another, the derivative in terms of another variable, this is how you can change it. If I want to simplify this thing, I can show that this is correct, because you can see dy by dt. If you write the multiply division sign at your multiplication, this would become reciprocal. So this would become dt upon dx, isn't it? And then you can see the dt and dt can cancel out, and you will have the same dy by dx on the left side, dy by dx on the right side. So if you have any other variable as well, this is how you would change it. So your dy is the numerator of the first fraction, and dx is the numerator of the second fraction. Between them it is division, and they are divided by the small change in other, the third variable. You cannot, it's not necessary that you will have time, it can be anything else as well, but most of the time, 95% of the time, you will have this third variable, which is time. So they would give you any two of these. Let's suppose they have given you, you will find dy by dx yourself, they have given you dy by dt, and you will have to find dx by dt. And dx by dt and dy by dt is what? Rate of change, or change in y with respect to time. And this would also be change in x with respect to time, which can also be said to be the speed, isn't it? Change in displacement, change in the value, or the coordinate in y with respect to time. So speed of y or speed of x, isn't it? Something like that as well, if you want to understand. Now the question can come in like this. Let's find a question of the past paper. Mm, 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 mm. Mm. The third part is of concern right now. So the first part, definitely it will be the same differentiation as usual. So the first part, they're asking you to find the obtain dy by dx for the expression. So your y is 12, and if you bring the fraction, the denominator above, it's x square plus 3 power minus 1. And now we can differentiate it. So dy by dx will be equal to the minus power, the minus 1 comes down, multiply, so minus 12 and x square plus 3, and the power reduces by 1, so minus 2. And the derivative of the inside, it is 2x plus 0. This is your derivative. If you want to simplify, you will get minus 24x upon x square plus 3 whole square. So you have found the first part. The second part, all you people know how to solve this. This is equation of the normal. You will find the gradient of the tangent using the dy by dx at this point, and then you would do the negative reciprocal, you will get the gradient of the normal, and then you would use the gradient of normal and the point to find the equation. We know this. I'm going to skip to the third part that is of a concern right now. A point is moving. Now read this question. A point is moving along the curve. So there is definitely a curve like this. It can be anything, but there is a point that is moving along this curve like this. On the curve, it is moving on the curve, and as it is moving, the x coordinate is increasing at a constant rate of 0.012 units per second. So look, units per second. So this is the change in x upon change in time. This is the speed of the point in the x direction. So in the x direction, it is moving with the speed of 0.012 units per second. This is how you can translate your English into math. Find the rate of change of y as the point passes through P. They're asking you to find the rate of change of y. So dy by dx. What is the speed in y direction for this point? We don't know this. When it is passing through P. P is 1, comma 3. Now you can see it is, you have not on the third variable as well. It is time. So first of all, if you bring in the formula that we knew, that is the dy by dx, it is equals to, look, dy divided by dx like this, and the other divided by dt divided by dt. This is your formula. Now they have given you this dx by dt. It is increasing. Increasing means that the gradient is positive. So it is positive. So this is given to you 0.012 positive. And this is what they have asked you to find, dy by dt. Now you can find the value of dy by dx. This is something that the value of dy by dx, you will find it using the derivative that you have found. So dy by dx at this p value, it is minus 24 times 1 upon 1 square plus 3 whole square. So this would become minus 24 upon 16, which will be minus 3 upon 2. So now you have the value of the dy by dx at this point, minus 3 upon 2, negative. And now what? You want to find this dy by dt. So this is dividing over here. It would go over there and multiply. So this means that your dy by dt, it is equals to negative 3 upon 2 multiplied by 0.01512. So your answer is coming out as negative 0.018. This is your answer. This is the speed of the point which is passing along the curve in the y direction, dy by dt. This is how you would do it. And the main formula is this. Okay, so they have given you the volume of the spherical balloon is increasing at a constant rate of 50 centimeter cube per second. Now using this, the units as well, you can identify this as volume per time. So this would be dv upon dt, and it is constant, and it is equals to 50 positive centimeter cube per second. So this is how you have to understand the statement. Then find the rate of the increase of radius. So they're asking you to find dr by dt when the radius is 10 centimeter, and the formula between the relationship between the volume of the sphere and the radius, it is 4 upon 3 pi r cube. So whenever you have this rate of something increasing per second, so definitely you would have to use the rates of change formula. So d, right now the formula, the variables are dv upon dr is equals to dv divided by dr upon dt upon dt. Now we already have the dv upon dt, it is 50. We have to find this dr upon dt, and we can find the value of dv upon dr at this radius value, at the radius 10. So we will find the derivative first. So if we differentiate this thing with respect to radius, so dv upon dr, it is equals to 4 upon 3 pi into 3r square. So the 3 and this cancel out, and now at radius value 10, the value of dv upon dr, it is equals to 4 pi 10 square, which will be equal to 400 pi. So this is the value of dv upon dr at radius 10. So 400 pi, it is equals to 50 divided by dr upon dt. Now this dr upon dt is dividing, it would go over there and multiply. And 400 pi can be brought down in the division like this. So this will become dr upon dt, it is equals to 50 upon 400 pi. 0 0 cancel out, 1 and 8. So this is equals to 1 upon 8 pi. This is how the radius is increasing. This is your answer. Okay, I'll do two more and then the next one you people will try. Okay, so the volume V meters of a large circular mound of iron or radius r, volume V, is modeled by this equation. V is equals to 3 upon 2 r minus 1 upon 2 whole cube minus 1 for r more than 2. Iron ore is added to the mound, what is this, at a constant rate of, okay, so look, the volume is given to us, d volume upon time, it is given to us, it is 1.5 meter cube per second. Find the rate at which the radius is increasing. They're asking you to find the rate at which radius increasing when radius is 5.5. Now this is very similar to the last question. So first of all, find the derivative dv by dr. We know the bracket comes down, sorry, the power of the bracket comes down, multiply, so 3 upon 2 into 3 r minus 1 upon 2, power reduces by 1, 2, and the derivative of the inside, it is 1, only 1, 1 minus 0, and outside you have a constant minus 1, that would also become 0. So the value is 9 upon 2 r minus 1 upon 2 whole square, and we want the value of dv by dr at the radius value. They have given us the radius value is 5.5. So the value of dv by dr, it will come out as, you can use your calculator, 9 upon 2, 5.5 minus 0.5 whole square, 112.5. This is the value of the dv by dr. Now bringing in the formula, dv by dr, it is equals to dv divided by dr upon dt upon dt. Now we have found this to be 112.5. dv by dt was given to us 1.5 divided by dr upon dt. So this means if we make dr upon dt the subject, it would again be 1.5 upon 112.5. 1 upon 75 meter per second. Isn't it? Radius per time. This is the answer. Then find the volume of the mound at the instant when the radius is increasing at 0.1. So they have given you for this part the dv by dt we already know. It is 1.5 meter cube per second. And they have given you in the second part dr by dt as well. Look, zero point 0.1 meter per second. They are asking you what is the volume of the mound at that time. Now using these two, dv by dt and dr by dt, we can find the value of dv by dr because we can see the formula over here. So this means that dv by dr will be equal to dv by dt is 1.5 divided by 0.1. It will be equal to 1. It will be equal to 15. And now we have the value of dv by dr, and it is equals to the function of dv by dr is 9 upon 2 r minus 1 upon 2 whole square. And now I can find the value of r. The 2 will go over there and multiply with 15. Okay, 2 times 15. And the 9 will go over there and divide. So divide by 9. 10 upon 3. 10 upon 3. Okay, and then you would do square root. We have 10 upon 3 is equals to r minus 1 upon 2 whole square. So it will become square root. Square root of this 10 upon 3, it is 1.826 something, plus minus 1.826. I don't have some this place over here. So plus minus 1.826 and plus half is equals to the radius. So the radius is, you will get two answers for radius. This thing plus zero point 0.5. So your radius one is 2.326 and your second value of radius is 1.326. Out of these two values, we would choose the value of radius which is more than 2. This answer, because they have given us the function is only working for the radius value is more than 2. So we would only consider this radius value, 2.326. But the question is still not complete. They are asking you to find the volume. We have the radius. How will you find the volume? We can use the original function, this original function again. So the volume will be equal to, we don't have the space, 3 upon 2, radius is 2.326 minus 1 whole cube minus 1. You will use a calculator. 2.50 something, if you round it off, meter cube. This is your answer, final answer. ठीक है? Getting it?
सर पार्ट ए एक बार दोबारा समझा दें.
Okay. In the part A, they have given you, if you read the question, they have given you the function relating the V and R, and the radius is more than 2. And they have given you the iron ore is added to the mound at a constant rate. Rate is given to you. Look for the volume. This is meter cube. So this is the volume per second. So we have the dV by dt value, 1.5. Now they're asking you to find the radius, the rate of increasing radius when radius is 5.5. So they are asking you to find dr by dt when your radius is 5.5. So if you use this formula, you have this formula, right? And you already have this value. They're asking you to find this value. You already have this value, and you can find this one using the function that you have. So if you differentiate this function, you will get dv by dr. This is your dv by dr. And then I found the value of dv by dr when my radius is 5.5. That's when they asked it. So when my radius is 5.5, I use the calculator. I got the value of dv by dr as 112.5. So in the formula, I replaced this 112.5. I already had this 1.5, and now I wanted to find this dr by dt. So this is dividing over here. It would go over there and multiply, and this would come down and divide. So 1.5 divided by 112.5. So yeah. Okay, this is the last one I'm doing, and then the next one you people will do. A curve has this equation: y is equals to x square minus 2x minus 3. A point is moving on the curve in such a way that the p at t the y coordinate is increasing at, so they have given you dy by dt increasing, so 4 units per second, and the x coordinate is increasing, so they have given you the dx by dt as well. It is 6. And then find the x coordinate of p. They're asking you to find x coordinate of p. So definitely this is the rate of change formula. So thing, so dy by dx, it will be equal to dy divided by dx divided by dt divided by dt. So if you divide the two values that they have given you, dy by dx, dy by dt, it is 4, divided by dx by dt, it is 6. So now you have the value of the dy by dx. It is 2 upon 3. And you can directly, easily, you can find the value of the dy by dx as well, and you can replace it over here. So the derivative is, you can see it will be simply 2x minus 2. So you can replace the dx dy by dx, so 2x minus 2, and now you can find the value of x. This would become 8 upon 3. X would be multiplied by 2. The 2 will go in the division. So this would become 4 upon 3. So this means that the value, the x coordinate, is 4 upon 3. This is your answer. This is the x coordinate at P. If they also want the y coordinate, then you can simply substitute this value of x in the main function, original function. You will get the y coordinate as well. ठीक है?